Okay, so this is a lecture for lesson 53. It's just going to help you do your homework tonight. Let's think about our rules so far for exponent rules so we know. Who remembers one? Excuse me? I said power rule, not power, you know.
Sorry.
Okay.
I can't take notes. You're all like, who you have to take notes? I can't take notes because my pencil's not sharpened.
Okay. All right. Power. So what do we know? What kind of power rules do we know? Exponent rules. Yes.
I know if it's 4 to the third power, you don't multiply it 4 times 3, it's 4 times 4 times 4.
Right. So if we had 4 to the third, that's 4 times 4 times 4. Okay, Sal.
If you
How about same bases times
same basis times same basis,
with
you
exponents?
add exponents.
Yeah, you add. So how would you write that? X
X
to the
to the
n
n times x to the m
times x to the m is equal to x to the n plus m. Okay. What's another one? You guys taking notes? Okay. All right. What's another one? What about dividing? How about same bases? What if you had x to the n over x to the m? It's x to the n minus m, right?
Well, those exponents are really
Right?
those exponents are over the x.
What?
Those exponents are like over the x.
What? What?
The exponents are higher than usual.
Oh, those are high? Okay, sorry. They were smoking something, I think. So, okay. All right. So all right. So how about this one? How about x to the negative n? What would that equal?
1 over x to the n.
How can they stand this? Okay. Okay, 1 over x to the positive n, right? Let's see if I'm forgetting something. Oh yeah. What about this? X to the 0
Equals 1.
is 1. Okay. Did I forget anything? That's basically it. So what about our new one? A power rule for exponent. What if you had this? X to the m raised to the n power.
Wouldn't it be like x to the m times n? I don't remember.
That is correct. So think about it. Let's do an example. Well, I'll write the rule first. It's going to be equal to x to the m times n. All right? What do parentheses always mean?
Everything.
Multiply, right? Yeah. So if you have, this is the only time you multiply exponents. It's when there's a parenthesis between the two. See how there's a parenthesis between the m and the n?
Yes.
Parenthesis means multiply. So you just multiply the m times the n. So if I had 2 to the 3rd power raised to the 6th power, right? That would equal 2 to the 18th power. Now, another way to think about it, if I did this the long way, it would be 2 to the 3rd times 6 is what? It's 2 to the 3rd times 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 2 to the 3rd. So there's 6 of them. 1, 2, 3, 4, 5, 6. You agree with me that that is the same as that?
Yes.
Yeah?
If you say so.
Right? So, and if we use this rule, what would we do? It would be 2 to the 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18. Look at that.
3 times 6.
Right? So this is algebra. This is the shortcut. Right? This is the long way. This is the short way. This is awesome. So that's why learning this rule, if you have something raised to a power raised to another power, you multiply the powers. Okay? Okay? Now I'm going to show you one example where it's even a little trickier. I'm going to do with erasers. I'm going to erase this, I guess.
Would you add the powers or what?
What if, where, on this one?
Yeah.
Yeah, this one would be 2 to the 3 plus 3 plus 3 plus 3 plus 3 plus 3, which is 2 to the 18. Right? That's the long way. This is the short way. If you memorize this, and really it's not hard to memorize because you know parenthesis means multiply. So m times n. Right? It's pretty easy to remember. Now, what if I did this to you though? What if I said x squared y cubed raised to the 4th power?
So would you do like distributed property with the exponents or something like that? I don't know.
Yeah, exactly. Exactly. Because it says 4 times this and 4 times
It would be
this.
like x to the 6th.
So it's going to be x to the 8th,
Yeah.
right? 2 times 4 is 8. And then y to the 12th. Okay, does it make sense? All right. Let's say we did this one. A to the 10th, B to the 115, all raised to the 10th power. It would be A to the 100, B to the...
1,150.
Oh,
Right.
imagine actually writing that out.
All we had to do is add a 0 to the end of
Gary,
it.
can you write that out so I understand better?
Yeah, let's do that the long way. That would be really fun. I would love to do that.
Yes, yes, yes.
I would love to do that, Andrew. Thank you so much. Actually, I don't want to spoil it. Why don't you do it tonight for homework in addition to your other homework, and then bring it into
I
me?
don't think
How are you doing,
You're
Gabby?
busy. Okay.
I would, Gary, but I don't understand. That's why you have
But
to write
thank
it.
heavens we know that shortcut, right? Thank God we know that shortcut, because if we didn't, we would be here for a very long time figuring that out. So it's 10 times 10 is 100. 10 times 115 is 1150. Great, we're done. Now what if I did this? Now I'm going to throw another curveball at you. What if I did this? 2, guys listen, watch. 2x to the 5th squared.
Doesn't the exponent
Now,
only affect
the question is, this is multiplied times every exponent, but is there a hidden exponent in there that you don't
Yes.
see? What is it, Hunter?
It's 2 to the 1.
Yes, it's 2 to the 1.
So would it be like
2 to the
2
squared.
2 and
X to the 10.
X 10.
Yes. So what is 2 squared?
4.
So your answer would be 4x to the 10th.
4x to the
Right? You see that? This is where a lot of people mess up with these. Is they'll see the 2, they don't see the hidden 1 exponent. And they'll say, oh, it's 2x to the 10th. Right? But it isn't 2x to the 10th. The 2 to the 1 times 2, x to the 5 is 2, which is 4x to the 10th. So what would this one be? 4x to the 100 squared.
Oh,
What would it be, 100?
it would equal 4 to the second
Okay, because there was a 1 there. Right?
x to the 200.
Yes, good.
Which would equal like
16x to the 200. All right, one last one. 5x to the 6th cubed. All right, Tess, help me. So 5 to the 1, right? So, well, 3 times the 1, you're only multiplying this times exponents, right? right? Good. And then what is 5 times 5? What's 5 times 5? Right. And what's 25 times 5?
125.
125. So 125 x to the 18. All right, last one. I know I said that already. 6 x to the 11th squared. Column.
It would be 6x squared.
Say what?
It's 6x squared, right?
Well, no. So this is going to be multiplied times each exponent. What's the hidden exponent? Right? So 6 squared.
I know that. Oh,
You said 6x squared. Okay, 6 squared. Yeah. And what's that final answer? What does an exponent mean? 6 times 6. That's 6 plus 6.
Oh. 36.
Right? Yes. Okay, good. All right. All right. So that's called the power rule for exponents, okay? It's because the power is raising another power. There's one power raising another power. Say what? Well, it does.
I mean, next one.
Well, yeah. Okay, sure. So yeah, that's totally possible. So you could have 3 cubed, right? X to the 8th, all cubed. So it would be 3 to the 9th, right? And then x to the 24th.
So it would be 27 x to the 8.
Well, that's not 27. That's 3 times 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 3. I think. Right? Which is a big number, right? Because 3 times 3 is 9, times 3 is 27, times 3 is something. Times 3 is something, times 3 is something, times 3, it's going to be a big number. Yes. Yeah, so when they're huge numbers like that, just write it like that. Don't worry about that.
Is it possible to have an exponent that has an exponent?
Yes. Totally possible. You don't see it very often. I'm trying to think if I've ever seen it. Exponent with an exponent. Sometimes I do it by mistake when I'm writing your homeworks, because I'll forget to. Because when you do math on a computer, whatever. So it totally worked. It can be done. I'm just trying to think of when I'd use it, but it's a good question. I don't know the answer. I mean, I know it's possible. I just don't know. I don't know where you'd use it. All right. Now we're going to just quickly talk. That's that. Now we're going to flip gears, switch gears. We're going to talk about conversion of volumes. Right? So if I wanted to convert, remember a volume? What is a volume? Cubic something or other.
Something that fills something else.
So, can you? All right.
It's like how much stuff is there.
All right. So this is say 3, and this is 5. What's the volume of this?
15. 15.
That's the area.
Come on, guys. What's the volume?
Oh, it's 16.
What's the unit?
16 something.
So what's the problem? It's only yeah. A volume is only for 3-dimensional shapes, right?
Oh, I thought you were talking about the first.
Thank you so much, Jay. Appreciate it.
Gary wants to eat ice. But Gary, that's 3 plus 5, but it's a square. It's 3 and 5, but it's a square.
became correct.
So this is, I don't know, how long is this? 3? 2. Let's make that 2.
30.
It's so tiny.
30, whatever units it is.
So the volume, okay, and we're going to call them inches, right?
30
So the
inches
volume for this is equal to 3 times 5 times 2 inches times inches times inches, right? So it's 3 inches times 5 inches times 2 inches, which is equal to 3 times 5 is 15 times 2 is 30. 30 inches, 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 which is inches cubed, right? Inches cubed. Now, I do not want this in inches. I want it in, not inches cubed, I want it in centimeters cubed. So, I want you to convert 30 inches cubed to centimeters cubed. Okay?
Oh, you do
Now,
conversion factor.
first of all, what's my conversion factor go from inches to centimeters?
2.54.
So, Alex, conversion factor for going from inches to centimeters. No, tell me the conversion factor. Yes, good. All right, so now I'm going to do this. I'm going to do 30 inches times inches times inches, because that's cubic inches over 1. And look, I'm only trying to go to cubic centimeters, so this is going to take me to centimeters.
There's going to be 1,
So,
2.54 centimeters.
yeah, I have to have inches downstairs now, right? But look, I'm going to have inches 3 times downstairs in order to get rid of these 3 upstairs. So I'm going to use the same unit multiplier, the same fraction, 3 times. Right? Does that make
So
sense?
if you like 2.54 and 2.54.
So yeah, so you're going to have 2.54 centimeters over 1 inch. That crosses out one of those inches times 2.54 centimeters over 1 inch. That crosses out another one times 2.54 centimeters over 1 inch. That crosses out the last one. And look what I have left. Centimeters times centimeters times centimeters is cubic centimeters, right? And so if we multiply that out with a calculator, 30 times 2.54 times 2.54 times 2.54, we would have our answer in centimeters cubed. I don't have a calculator, so that's what you do.
You could just say like 30 times 2.54 centimeters.
So yeah, we could do that. We'll use our that 30 times 2.54 centimeters cubed, right?
Yay!
Now we're using our powers. That's good. That makes sense.
For power.
So that's it. That's how you do them. Is there questions on that?
Well, we have to actually multiply that out into our homework.
Technically, no. I mean, like when I look at the answers in the back of the book of Saxon, they're usually like this, something like that. You know, because in some ways, it's better to show what you've done. You know what I mean? You can sort of see how you figured out the answer. And everybody can use a calculator to do that. You know, to get the answer. But so, anyways, that's all you really have to do. Okay. So, okay. Do we need to do any more, or do you get it?
Good. This side, you only have a minute.
I think that would be a good place to stop. Okay. All right. That's it.